So I'm starting this series from the absolute basics because, to really get a handle on system design, we have to be super clear on the fundamentals. So for this very first explainer, let's just tackle that big foundational question. It seems like a really simple question, doesn't it? But I think getting clear on this is the bedrock for everything else that comes after. It turns out it's about so much more than just the code we write. Okay, so here's the plan for our little journey today. We're going to talk about why a system is way more than just lines of code. Then we'll get into why asking good questions is the real first step, not drawing diagrams. After that, we'll look at how to actually sketch out the big picture, touch on the art of making trade-offs, and wrap up with how design is really just an ongoing conversation. All right, first up, let's tackle the biggest misconception right out of the gate, the idea that software is just code. It's totally natural to focus on the code, right? I mean, that's the part we're actively writing. But a real system? Well, that's all about how a bunch of different pieces work together to get something done. It's the interaction that's key. I really like this definition. It's simple, but it's powerful. The most important words here are group of components and working together. It's about how things interact, remember state, and behave over time. It's almost like a living organism in a way. So what are those components really? Well, you can usually boil them down to these four things. You have the code, which is the brains of the operation. You have the data, which is the memory. You have the infrastructure, which is the body it lives in. And you have the users, which could be people or even other systems. And think about it. If you take away any one of these, you don't really have a system anymore. To make this all feel a bit more concrete, let's use a really simple example we can all understand. A URL shortener. Like tinyURL. It might seem small, it might even run on just a single computer, but it's a perfect little system to help us explore these ideas. So even with our little URL shortener, you've got all the pieces. There's an API, so you can create new short links. There's a database to remember the mapping between the long URL and the short one. There's a server whose job is to handle clicks and redirect people. And of course, there are users actually clicking the links. See, all four components are right there, working in concert. It's a whole system. Okay, so if a system is really about all these different parts interacting, well, it kind of makes sense that we can't just jump in and start building. First, we need to figure out what those interactions are even supposed to do. This is so important. I think it's the most common mistake. The first step in system design isn't to open up a diagramming tool. Nope, it's asking questions. It's all about getting a deep understanding of the problem you're trying to solve, who you're solving it for, and all the ways it could go wrong. And the questions we ask usually help us define two kinds of requirements. The first are the functional ones. That's the what. What does this thing actually have to do? For our URL shortener, it has to shorten a URL and redirect it. Simple. But then you have the non-functional requirements. That's the how well. How fast does that redirect need to be? How often can the service be down? That distinction is where all the interesting design decisions start to happen. And here's the thing. You never really get all the requirements perfectly up front. It just doesn't happen. I think this quote here really says it all. You're always discovering new things as you go, which is exactly why asking questions isn't just a step at the beginning. It's a process that continues the whole time. Okay, so once we've asked a ton of questions and we have a pretty good feel for the requirements, now we can start drawing some boxes. Now we can actually start visualizing what this thing might look like. And a really helpful way to start is to follow a pretty simple process. First, just identify who or what is interacting with your system from the outside. Then, think about the big, major chunks inside your system. And finally, figure out how all those chunks are supposed to talk to each other. The key is to start really zoomed out. A context diagram is perfect for this. You basically treat your entire system, our whole URL shortener, as just one single black box. All you care about is what's talking to it from the outside world. This helps you understand where your system fits into the bigger picture. After that, we can zoom in one level. We crack open that black box and look inside. A container diagram shows those major internal pieces we talked about earlier, like the API, the database, and the web server. This is really our first sketch of the system's architecture. So this whole process of choosing what components go inside the box and how you draw the lines between them, it leads us to what is probably the single most important fundamental truth about system design. I just love this quote because it gets right to the heart of it. There is no one single right answer in system design. It's not like a math problem where you can prove the solution. It's really more of an art. It's about making a series of smart, deliberate compromises to best meet the requirements you have. And you're always balancing these competing concerns. I mean, take scalability. We all want our system to handle millions of users, right? But to do that, you're probably going to need more servers, more complex code, which means it costs more and is harder to manage. That's a trade-off. Or what about availability versus consistency? To make sure your service is always up, you might keep copies of your data in different places. But that means, for a brief moment, two users might see slightly different data. You've traded a bit of consistency for better uptime. Every single design choice is a balance like this. So let's just take a moment to pull all of this together and recap the main ideas we've walked through today. These are really the core ideas. A system is a team of components, not just a blob of code. The design process starts with questions, not diagrams. Visualizing is a tool for thinking, moving from the outside in. And maybe the biggest takeaway of all, there's no perfect answer, just a series of well-reasoned trade-offs. And this really is the final point I want to leave you with. This whole approach, this way of thinking, it's not just for massive global scale services. This applies just as much to a simple to-do list app you might build for yourself. It's a mindset, not something that's tied to scale. And that kind of leaves us with a fun question to think about. The next time you open up your favorite app, just pause for a second and wonder, what trade-offs do you think the designers made? Did they prioritize speed, or making sure the data was always perfectly consistent? Or maybe keeping costs low? It's a pretty interesting lens to look through. And that's day one.